introduce to you Dr. Dirk Vetter. Dr. Dirk is an independent security consultant with more than 18 years experience in information security, even more in the world of Unix and Linux. He's engaged in OWASP Germany and Europe and has chaired a couple of different conferences. Whenever possible, he's using open source software. He's developed an open SSL TLS tester for the command line named testssl.sh, which is using network sockets. A lot of us in the security industry feel that HTTPS has gotten much better. There are so many controls that make this standard very powerful. However, there's still significant privacy issues even when doing the best configured HTTPS. Dr. Vetter, thank you.
Thank you, Ray. Thanks, Jim. I go by the name Dirk. Thanks for the kind introduction and thanks for welcoming me here. So welcome to my talk also. Well, I added the S because the table overview, they just forgot the S. Don't know for some reasons. On other places, it's there. I also added a subtitle because I'm done. Okay. Oh, sorry. In joke. I also added a subtitle because there are a lot of things which you can spot with encryption and also if you're using, for example, VPN or Tor. So Jim talked a little bit about me. In September, I have 20 years anniversary to get money for working in the IT industry. I'm a consultant working for myself. As you maybe know, I'm German and I'm very old, so I value privacy very much. Besides having a real life, I also do have some IT-related hobbies. Isn't that sick? Somehow, Jim mentioned some OWASP activities I had. I'm currently also chair of the German board. Chaired the AppSec research conference in Hamburg, which is my hometown, and and also developed an SSL tester or TLS tester. Okay, let's get started. What's the motivation of the talk? I sensed some overreaction regarding privacy and encryption. There was a lot of, in my opinion, nonsense out there when it comes to encryption, especially when talking about application protocol, HTTPS, and privacy. I would like to remind you about the basics, what if can tell when you, for example, the audience Bob, will talk to Alice, looking just at the wire. I want to talk about sins in the past. This was from our last year's keynote speaker, Troy Hunt, a copy of his blog where supposedly it wasn't clear where other sites had encryption enabled while entering the credentials. I'm not talking about this. I'm not talking about that either. That was the German site, which a couple of months ago still had a problem doing full encryption of their website. So my name there and also there went in clear text over the wire, probably. And also I'm not talking about that company who has showed me my inbox without encryption over there. We all know this is, okay, I spoiled it kind of. This is bad, okay? I'm not talking about this. I'm more relating, for example, to talks like this. For example, if a key player in the internet is saying that sites who don't switch to TLS or SSL don't care about privacy about their users. That's really tough. Maybe the speaker was confusing privacy with confidentiality, and certainly on the same line, right? Generally, it depends on the information security values which you have here on the site, whether you want to encrypt or not. A site like mine, probably you don't know it. Test SSL, for example, doesn't have any security information values, and also everything which I have on my site, which is for downloading, for example, is PGP signed, which is maybe even a stronger thing than transport layer encryption. So what is the point and why I'm being blamed? This is something which I want to explain during the next slide. Well, first of all, one step back. Let's get back to Google. After the other, for example, talk, they said they're using HTTPS as a ranking signal. So they start to punish sites which don't have HTTPS enabled without really looking at the site, whether it has some values like confidentiality, integrity, or availability reasons. They were saying to keep everyone safe on the web, but there was no explanation well, why safe. So after the Snowden revelations and Google's pressure maybe in the public, several others hopped on the train and said, oh, we need HTTPS, we need HTTPS. And one of them, that's the most remarkable thing I like to pick here or present here, was the IETF, the institution, or one of the very few institutions which publish internet standards, the RFCs, right? So there was something in the mailing list and also on the website, if I remember correctly, which says, I'm reading it, the IETF has recognized that the act of accessing public information required for routine tasks can be privacy sensitive and can benefit from using a confidentiality service, such as provided by TLS. The IETF, in its normal operation, publishes a significant volume of data, such as internet drafts, to which this argument applies. What? What is that? That seemed kind of absurd to me. Why should an RFC, for example, which is published on the internet side of IETF, benefit from confidentiality or from encryption, right? They're now talking about integrity. Well, there were several outcries from the mailing lists. Two things I like to present here. One was from the inventor of the good old HTTP 1.1 protocol, Roy Fielding. Browsers don't send singular messages containing anonymous information. They send a complex sequence of messages to multiple parties with an interaction pattern and a communication state. Okay, that was probably a correct answer. Tony Hein topped that a little bit and was more honest in saying, while I don't object to making the IETF content available via HTTPS TLS, this proposed statements read as political knee-jerk bullshit that is both unnecessary and uncalled for. What the statement must focus on is data integrity and should not stop to fear-mongering over privacy. It's public data, okay? So let me explain it why this is nonsense, in my words. A lot of people who studied, who studied informatics or IT, hands up. Okay, probably you all know this kind of diagram. It's the OSI 7 layer model, and there are also some layers which we are referring to, which is the IP layer, the TCP layer, and the SSL layer. These are the important layers when we talk about HTTPS or TLS encryption in general. So what you see here is a packet capture taken from the router with a Firefox browser while I was visiting the website Test SSL. You see in the very top, well, I kind of blurred the source address, the IP source address, but you see here the destination address which goes in clear text over the wire. You see also the port which goes over the wire, and you see also here, which is folded off, the SSL section. In the SSL section you see several protocols, several items, let's put it this way. You see cipher suites here, and you see some speciality which are called TLS extensions. Here's the length given, and you see, and then following all the TLS extension. And the TLS extension is something which is called like server name indication. So if you look at it, there's also hidden the host name, of course. So that was basically a clutch like 10 years ago or so, because the time before that, you could not only have per IP address one virtual host with SSL encryption on the same port. Otherwise, that wouldn't work. So you're signaling now, basically, with your browser. If you go to a website, every time when you go to the website, also the name of the website where you're going to. It's not only IP address. So what is great out here in the very top is my source address, which was, well, from a home network. So basically, that's a private address. It would have been worse if that had been IPv6 address. So IPv6 means also it has some privacy issue. It's a great thing because it has a broad address space for everybody, but it could be worse in terms of privacy. For Linux system, for example, it's not the best thing to use IPv6 if you're really privacy aware, at least not in the default configuration. If the client is not configured to use, for example, IPv6 privacy extensions, you're running through the internet with a unique IP address, right? Which can be tracked, of course. And it comes worse, for example, if you have stateless auto configuration for IPv6 enabled, that means that your MAC address is even in the IP address. For Windows, this is not the case, by the way. Of course, after the client, that was a client hello I showed before, now comes the server hello, which is the answer from the server. They're trying to negotiate on, well, the things they well, want to communicate with. The server hello is normally, well, spread over two packets, which you see here. This is the length on the wire. And it also contains, of course, the certificate. And in the certificate, of course, is the hostname. Okay. That was very basic stuff. What I kept back, that before opening URL in the browser, the name server, of course, has to be queried, right? So the first thing is until now, we have a point-to-point communication. Now a third party, or before a third party has been involved. So that means I'm querying somehow through other name servers the IP address of that. So this is also something, so everybody on the wire, then this is a clear text protocol. This is not encrypted. So everybody which reads the wire can make a correlation of this, for example. Then there's a step where nowadays also third parties are involved, which is called OCSP checks. This is a typically OCSP request. If you go to a website which is TLS encrypted, your browser checks against. There's in the certificate is a URL which your browser queries in order to get a clue whether the certificate has been revoked or not, right? As you see here, this certificate, this URL is clear text, and well, it can be queried by a post request or GET request. Normally, it's been done by a post request, and you see here in the post body encoded OCSP request. Of course, the OCSP request contains a couple of items. One, of course, is the item of the certificate serial number, which is taken from this RFC, which is basically taken from the IETF website. So basically, my browser talks then to OCSP godaddy.com whether that certificate has been revoked or not, normally, right? But there's a workaround or a privacy gain for some reasons, which is more for the server administrators to set up, which is called OCSP stapling. So that means not a server is being contacted for another third-party server is being contacted in clear text, to query whether the certificate has been revoked or not, the server holds a signed response of the OCSP responder and delivers directly, the web server delivers it directly to the browser. So that also has the advantage, OCSP has also, that has two benefits. One benefit is that if the OSP server would not be available in a non-stapling scenario, that would mean that it's up to the browser what they then do. Do they fail or do they just continue? It's hard fail or soft fail. If they fail, you cannot connect to the website. If they do soft fail, which I don't know what Google does or Chrome does nowadays, it did hard fail in the past, I don't know whether they still do it. If they soft fail, it's just not, it's just connecting. So the idea of the OCSP request, if it's HTTP, and you can just intercept the packet, is bad by that. Was also talked by Moxie Barlingspike how to intercept those requests. For example, OCSP stapling eases that because basically on the server response sends back the signed response. Okay, and it's also a privacy gain because no third party are being contacted. The catch is it's not enabled by default. For all servers which are out there, Apache, Nginx, IIS, you have to configure it manually. It's only a couple of lines. So there's another thing in the TLS layer which allows fingerprinting. You saw a couple of slides ago the client hello. I'm now showing again two client hellos. On the left-hand side, you see the client hello from Firefox. On the right-hand side, you see the one from Chrome. You see that there are differences, of course. For example, looking at the cipher suites, well, normally it works, a browser sends a couple of cipher suites to the server, and the server picks as far as cipher suites are concerned. This browser, this is the default Firefox browser, sends 13 cipher suites. That sends 17 suites to the browser. Also, you see a kind of mismatch in the extensions. There are a couple of extensions here, and there are a little bit more extensions there, right? So you can tell on the wire basically what brand of browser somebody is using. I don't have a picture for the Internet Explorer 11, but Internet Explorer has way more ciphers. It's not configured that strongly by default. So it's, for example, also fully patched IE11 browser has the ARC4 ciphers two pieces. And I counted of 26 ciphers, which an IE11 nowadays still sends. So that means Eve in the middle can still tell which browser you in the audience are using, right? If you're kind of paranoid, like I was in the past, and threw, for example, away some ciphers, like ARC4 ciphers, I didn't want to have ARC4 ciphers, you're having a unique fingerprint, also on the TLS layer, right? So it comes worse if you look at specific items from the TLS extensions. There's constant development in the field of TLS. With somehow good accuracy, you can even determine the version of the browser used. Here's Firefox, right? Those are the cipher suites which are being sent. So in Firefox 47, two new cipher suites or ciphers popped up, which are the so-called Chacha 20 Poly 13 or 5 ciphers. Wireshark doesn't know of it, so there's no resolution here, no name resolution here. And you see also here 3 elliptic curves. I'm showing also the picture. So Chrome, on the other side, has also those two ciphers, but also carries two old ciphers, which are the same ciphers like this one, but only in an old implementation, which is like 1 year old. So this came new, I think, in Chrome version 51, if I'm recalling correctly, and this is also specific to Firefox version 47. This is really without tampering with anything in the browser. Just also the elliptic curves which are being offered. Also in the client hello, browser says, okay, yes, here are my elliptic curves which I support. There are currently 30 curves, I think 30 curves. Those are those three, if you look at those. You have different curves here on the Chrome side. For example, the 521 is missing here, and you see also a curve here which also has no name resolution, which is called the so-called curve 25519, which is pretty new, and only currently the Chrome browser has this, right? So it's also you can also fingerprint the client on the client version exactly, right? With Internet Explorer, it's even more remarkable because the patches you get with Internet Explorer from Microsoft are bundled with IE. So normally you patch them both at the same time. So Microsoft also changes the specs of the client hello and the items in the client hello. So by fingerprinting an IE11 only on the TLS level, an adversary can probably also tell what the patch level of the operating system is. Speaking of TLS fingerprinting on the wire, I'd like to mention 2 to 3 interesting projects. One is basically the SSL Labs client API, which was, as far as I understand, the result of an Apache module which is called mod SSL HAF, which Ivan Ristich had put on GitHub like 2009 already. But I don't know whether it was GitHub 2009, but it's now at GitHub. Basically was collecting SSL fingerprints. So he has built up a database with TLS fingerprints on this. And this API nowadays, if you go to the website, this is exactly the API. You get a JSON output, which is really long, which tells you basically from a lot of clients, mostly browsers, what the clients are. The other one is the fingerprinting project from Lee Brotherston. That's an alternative approach, but also very cool. You can throw packet captures at it, but that means also somebody who recorded a session can later on determine what kind of browser you have. And also, it's not only browser, it's mail clients, it's mobile clients. And the funny stuff, it catches Skype, it catches Dropbox clients, also the hacker tools, wget and curl, even some malware, which is using SSL to phone out like Superfish. On the command line, it's very easy. If you just want to have some fun, you can, oh, there's a typo. You can just run it on the network interface and it shows you then the browser versions passing by. Okay, cool. Well, this is an old thing. Also, the TLS contains another item in the client hello, which has been used by Firefox and Chrome, but still is in use by Internet Explorer 11. I don't know how Edge does it nowadays. There's a TLS timestamp in there, which is normally for every other client a random value, but for Internet Explorer 11, it still has the local system time. This is here now because I'm living in this time zone. It's normally in UTC. It's in milliseconds, so it's very accurate normally. So what normally random, it's really random, would look like this, right? So Eve on the wire can tell, well, by just tracking browsers with the time, you can also the fingerprints better in the wire, because if there's a time drift, most people don't have protocols like NTP enabled, and also if they have, there's a likelihood that the time is not, as far as milliseconds concerned, not the correct one. So this is another possibility to track clients on the wire if the time's off for a couple of seconds, for example. Well, what about the URL at the target? It should be protected, right, if I switch on TLS. This is something, if I go to my GitHub page, and this is the Firefox console, I would like to give you an idea. So that's on the console, and I would like to give you an idea what Eve could see on the wire. Probably it sees, of course, the hostname, or let's say, the hostname and the IP addresses, right? It doesn't, of course, can figure out the type. Also, this is protected, but it sees what is remaining are the host names and the sequence where resources are loaded. But how about the transfer size? Do I see anything on the wire? So it's a little bit difficult. I give you some seconds to chew on. This picture shows the packets which are sent from the browser only back to the client. So related to the request I saw, I displayed in the Firefox console a couple of pictures back. I cut the picture here. There would be coming a little bit more. You see two server hellos responding to the client hello, which is not in the picture, from github.com. There were three on the slide from github.com. You see here 4 requests to assets -cdn.github.com. There were 5 on the slides on the Firefox console. And you also see the length of the packets on the wire. Application data means that this is where the actual content is being sent from the server to the client. So there's a physical, well, kind of physical size on the wire, which is the something which the client operating system and the server operating through all the routers negotiated. And basically any packet which is larger than this is being split, right? So this is why you see application data here. But you can look into them. So this is the same picture, only the different requests are colorized based on the port of the clients where this is being sent to, so that you can better tell which packets belong to each other. You see here the server hello, then comes the certificate, change cipherspec, and then comes the application data. Here for this server hello, you don't see anything else here, and in this picture yet, except change cipherspec and no application data yet. So here, green, this belongs to each other. There, this belongs to each other, and for this, for example, this should be over there. Okay. So it's not so much here to see. So how comes this, and why does it correlate that bad? Of course, the network view is pretty much different of the view the browser has. There are things like on the HTTP level, which is like pipelining, of course, which means several requests are sent at once. There are also persistent connections. There's caching. There are keep alives, even which so this makes matters worse even with HTTP 1.0, which doesn't support all of those features, there's not necessarily a second server hello, because also on the TLS level, there's something like tickets. So if I'm done talking to Jim with my TLS conversation and I decide as a browser to send him more packets, then I do not necessarily have to open up another TLS connection. If the server has been closed to the connection before, if Jim said no, stop, I have to open one. But if on the HTTP layer he said no, then I have to open one connection. Otherwise, I can reuse that one. So, how many 10 minutes do I have left? Okay, I think I speed up a little bit. One can do performance traffic analysis. I'm rushing through it a bit. So there are also several things. This is the Firefox console, which are really obvious. Some things are really unique for GitHub, for example. If you look at GitHub, avatars is, well, the avatar, this could be either a user logged in or you look at a website where only one avatar is being shown, right? Camo was one picture. For example, if you have a Gitter icon, Rego up, or Travis icon on the web page you're looking at, this request goes to Camo GitHub user content. This live github.com, a request to live github.com normally is a WebSocket connection which you find, well, let's say on 80% of the pages at GitHub, but not on every page. So an adversary could have a good guess, at least with some probability, what the person is looking at. Yeah. One thing I like to mention here, the Roy Fielding RFC HTTP 1.1 says, which is a good thing, that if you go to a website, for example, which is here encrypted, and you go to another website which does have HTTP here, normally what one would maybe expect is if you click on the link, that in the referrer header, the URL where you have been is being transferred to this page. But all browsers don't do that nowadays, right? I think I skipped that. What I did was a little bit poor man's analysis. There were researchers out there. The first paper I found, it goes by the name website fingerprinting, right? The whole thing, the traffic analysis or website fingerprinting. It's kind of scary what the researchers are telling us. Sometimes it's being disputed whether this is true or not. I don't have time to go that much in detail because Jim is already pressuring me here. The first, to my knowledge, the first research published was in 2005 in the Privacy Enhanced Technologies Symposium. It says that based on the sites, it showed a guess accurate rate for a web page of a URL of at least 23 to 40%, which is quite remarkable. Skip that one. This is a newer one which came out after the same symposium, PET symposium in 2014, so after the Snowden revelations, all those things became more important. And it says that, well, it's research more practical websites and not set up websites, and it said the results are even worse. This is like compared to the previous research 9 years later, that there's 90% accuracy for finding the resource on the website. Concerning privacy, this is miserable, I think. Okay, The results, I should say, the results of such research are sometimes criticized because they don't take, one thing also is the history of browsing, whether it's being researched in a serial manner, or whether it's tab browsing, which means you open a tab and then care about the tab later, which means basically parallel browsing. But at least I believe there's really substantial work has been done also for public sites to track users, which is also important, for example, for the onion router network, or Tor and VPN users, because some people want to track or want to look what's going on the wire, and from the exit node to the server, people want to know where people are looking at. So now comes the nasty thing. I'm not talking about the late singer, bass player in the picture. Actually, I kind of liked him and his music. Opposed of that, what I do not like on the pictures are the trackers. You see here, I'm surfing with Ghostery, and it has 27 trackers enabled. You also saw here the 27 trackers. As Lemmy died, I stumbled over this page. So if you talk about privacy, so this is HTTPS encrypted. Is that totally safe? Is that private? Everything, right? But trackers also don't threaten the privacy. Also posing. I'm now switching a little bit to security. They're also posing a security problem. If one of the trackers or ad providers has a problem, of course, the DOM of your browser has also a problem. Probably you know the term malvertising, right? There's been a couple of hacks where people got a hold of companies providing banners for websites and hacked all the browsers where the banners or ads were delivered. But this side, coming back to the Lemmy side, if you look at the Firefox console, had another problem. This is an excerpt from the console. You see there are really high number of trackers. Well, let's put it this way. First, you see on the Firefox console, one could see 250 GET requests to 81 hosts for just this page, which is enormous, right? I made some statistics. There was 49 mixed content blocked, but 51 loaded. If you look here, exactly, here's a form which is blocked. Here are also forms which are blocked. This looks like JSON, which is being blocked. This JavaScript, which is being blocked. But here you see also pictures which are being loaded. So how come the pictures are being loaded, right? This is something which people still tend to forget, right? If you have a browser, also a modern browser like Firefox or Chrome, parts of the pictures are still being loaded because it's passive content. SSL Labs, this is an excerpt from a test from an actual Firefox browser, latest and greatest version, which says that images, if I go to a website, are still loaded through an HTTP channel, also if the web page is encrypted. Due to the clear text protocol, of course, an adversary on the wire can, for example, this again security, not so much privacy, also privacy, but mostly security. Due to the clear text protocol, everybody in the middle, of course, could put some content on the instead of the picture being delivered in there. An ASCII track would have been, you cannot modify the DOM because it's passive content. But for example, what one you can do can a little bit do social engineering, for example, providing an error message or HTTP error message 401 so that people type in their credentials if they're somewhere logged on, and boom, you have their credentials, right? In nowadays browsers, you can't do so much against it. For example, Firefox, it's a good thing at least. I don't know whether it's possible in Chrome. You can switch it off using this variable, so that also those images would be blocked. Okay, but it's worse if you look, for example, at Android, which is version 5. You still also see that AJAX requests are being allowed here, which is bad. Okay, Android 5 nowadays, there's a web page from Google which says it's still being in use. They use it on the Play Store. So you can pretty much collect statistics. It's being used by 30% of all the users who are having an Android phone. So that is really dangerous here. It's worse because IE11 has a question which says in the very below, I don't have a picture for this unfortunately, there's unsecure content. Do you want to load it? Yes or no? Of course, every uneducated user would say, okay, why? Okay, I hurry up. Every uneducated user would say, okay, sure, I would load it. There's no explanation. There's a link where you can Google look it up, what the problem is, but it also means that scripts and CSS are being executed then over this channel. Well, old browsers, which is Firefox before 23, and old Android versions, which are not really in use anymore today, like coverage of each like 2%, are really worse at it. So they would probably load the whole Lemmy website without complaining. So let me quickly conclude the talk. What's the bottom line of using HTTPS? Of course, you should use HTTPS wherever possible. Content, of course, is protected, right? But of course, there's a leakage of IP address and host name, and more can be deducted by TLS fingerprinting. Also, the browser version can be detected. And if an adversary has enough resources, we can probably also do some website fingerprinting and find out where you're looking at. The real problem nowadays for privacy, in my opinion, are trackers. Yeah, as I said, that's also not pose a privacy problem, but also a security risk, by the way. And from Google, I find it quite unfair since they have trackers like Analytics, AdSense, and also own a company like DoubleClick, if they talk about privacy and switching on HTTPS. So, as I said, HTTPS is the right thing to do. Also, if you want to protect the content or the authenticity of the content, because it also provides integrity. There are also some benefits I showed you in terms of privacy, but real privacy is something different. So, even Tor or VPN only covers disguises the source address. If you don't mess, for example, with the Tor browser, you would be safe at least not to be tracked individually, and you have it. On the server side, nobody, well, I know there are business reasons, but if you care about privacy of your users, don't use trackers and throw away logs early enough or anonymize them. Do I have 2 minutes left? Okay. Actually, okay, let me go through it. Actually, HTTPS, the coverage of HTTP or the ratio of websites which are encrypted is not so bad. The world we are living in is really bad. The statistics, this is from the Network and Distributed System Symposium from December. It states that only 30% of the emails which are delivered over SMTP and StarTLS are probably encrypted, so that means the certificate is probably checked. But StarTLS is opportunistic encryption, so every intermediate can strip off the clear text communication and do a man in the middle. So IMAP and POP is a little bit better. Java, which is a chat protocol, which nobody probably uses amongst you. Is anybody using it? Java, XMPP? Hey, cool. Okay. With VoIP or GSM, it's even worse. Everything in the backbone is not encrypted. So, before Jim is throwing me off the stage, I'd rather finish. Thanks for having me, and yeah.
This concludes the defensive track for the day. As you're heading out, there are both red and green cards. Please grab one to evaluate what you thought of the talk. The closing remarks are happening in the main room right now. We're running a bit late, so thank you very much for being here. And 7 o'clock, the buses